Imagine you have a time machine and can travel back in time, all the way to the very beginning of the universe. What if I told you that you could witness the Big Bang with your own eyes? What would you see? A massive explosion? A blinding light? Let's find out together. Before we travel that far back in time, let's pause for a moment to think about what the universe looks like today. Look up at the night sky, and you'll see millions of twinkling stars, distant galaxies, and, of course, the vast darkness of space that seems to stretch on forever. But has it always been this way? What if you had supervision, capable of seeing beyond visible light? What more could you discover? The answer lies in a faint glow from far, far away, the famous cosmic microwave background radiation, the light left over from the Big Bang. This light is almost like a photograph of the universe's beginning, a kind of cosmic memory. It guides us as we travel back in time. Imagine if you could equip your eyes to see beyond what we normally can. You would see this glow, a dim light that weakens as the universe expands. Isn't that incredible? Now let's get back into our time machine. As we rewind further and further into the past, everything changes. The universe 13.8 billion years ago was a very different place. There were no stars, no planets. What you'd see would be far simpler. A vast, bright sea of light without any distinct forms. The universe was just beginning to take shape, and the light from the Big Bang was like a soft haze, similar to the warm orange glow of a candle flame. At that moment, you wouldn't see galaxies or stars. There wouldn't be a sky filled with dazzling light and colors as we know it today. Instead, you'd witness a massive pulse of light, as if the universe were announcing, "I'm here. I'm beginning to exist." And the most amazing part? That light you'd see is the same light that continues to travel across the universe, providing clues to scientists about how everything started. It's not like you'd be seeing the beginning of the universe in a conventional way, but rather experiencing the soul of the Big Bang conveyed through light and heat. So, what would you see if you were there? No explosions, no fireworks, just a soft glow, the start of a grand story. And this story, the story of the Big Bang, is our story. It's the story of everything and everyone. Have you ever thought about that? You, the universe, and everything that exists are part of this incredible cosmic journey that began billions of years ago. Shall we continue our journey and see what happens next? Have you ever stopped to think about how cold the universe is? Incredibly cold. If you were in space without any kind of protection, you would feel a chilling minus 270 degrees Celsius. That's just a fraction above absolute zero, the coldest possible temperature in the universe. What's fascinating is that this extreme cold is one of the most striking features of our current universe. It's almost devoid of heat, and there's a very interesting reason for this. The universe is constantly expanding, and as it expands, it becomes colder and colder. But don't worry, that doesn't mean it's completely empty. On the contrary, space is full of incredible things, and even in all this cold, it has many stories to tell. Did you know that even with this extreme cold, we can still see stars and galaxies shining in the sky? But these lights aren't exactly like the ones we see in a lamp or a campfire. They come from a very small spectrum of light, a tiny slice of the rainbow that our eyes can detect. The light we see is just a fraction of what's out there. There are other types of radiation and waves, like X-rays and radio waves. But what our eyes perceive is only a small part of the vast variety of light in the universe. And all of this is a result of the incredible story of how the universe was formed and transformed over billions of years. But there's something even more fascinating: the cosmic microwave background radiation. This radiation is like an echo of the Big Bang. It's everywhere, traveling through space since the moment the universe began to cool down, back in the beginning. Although it's very faint today, it provides a crucial clue to understanding how the universe started. If you could listen to this radiation, it would sound like a faint murmur, carrying vast amounts of information. Every bit of this radiation helps us understand what happened right after the Big Bang, when the universe was still taking shape. What's surprising is that even with all this cold and the vastness of space, the universe still has incredible energy. That might sound strange, right? How can a place so cold and vast be full of energy? The answer lies in how stars and galaxies interact. They are born, live, and die in awe-inspiring cycles, releasing light and heat throughout their journeys. And all of this happens in a setting that might seem silent at first glance, but if you pay attention, you'll realize the universe is telling its story every second. So, what do you feel when you look up at the sky? What goes through your mind when you think about this immense and mysterious universe, so cold, yet so full of life? As we continue our journey through the cosmos, let's uncover more of the secrets it holds for us. If you could look at the universe 10 billion years ago, the scene would be a bit different from what we see today. While space was still extremely cold, something incredible began to happen. The universe, which had been expanding slowly and steadily, started to accelerate. This phenomenon was driven by a mysterious force scientists called dark energy. This energy, which occupies most of the universe, has the ability to push galaxies farther apart, causing the universe to expand faster with each passing day. But despite this acceleration, the universe was far from comfortable. Even with the expansion in full swing, the temperature was still too low for any form of life as we know it to emerge. If you were floating in space, feeling the biting cold of minus 270 degrees Celsius, you would realize that the universe was still far from being a hospitable place. Dark energy was making space stretch wider and wider, but there was still nothing to warm it or bring life to it. This process of accelerated expansion also makes us ponder what might happen in the future. Will this acceleration continue over time? Could the universe grow so vast that stars and galaxies will be pushed so far apart that the space between them becomes so immense that light will never be able to reach us again? This is one of the great mysteries brought to light by dark energy. It's remarkable how, even without fully understanding what dark energy is, scientists know it plays a fundamental role in shaping the universe's destiny. Today, it dominates the cosmos and continues to influence its evolution, accelerating the expansion while keeping the universe cold and empty, a far cry from being a welcoming place for life as we know it. Now, if you stop to think about it, what do you imagine the future of our universe will look like? With dark energy pushing everything farther apart, what will the universe be like billions of years from now? Will it keep expanding until it becomes an even colder, more desolate place? Or will something change at some distant point? What we do know is that the universe is in constant transformation, and the answers are still out there, waiting to be uncovered. We've arrived at a fascinating point in the history of the universe where everything begins to take shape. After billions of years of dark and cold space, something truly special happened. The first stars began to shine. You might wonder, how was this possible when the universe was still such a cold and lifeless place? Well, after immense expansion and cooling, atoms started to form. But these weren't atoms like the ones we know today. They were primarily hydrogen and helium, the simplest building blocks of matter. With these atoms, gravity did the work of grouping everything together, pulling matter into enormous clouds. These clouds heated up so intensely that, eventually, they triggered the formation of the first stars. Imagine an immense cosmic furnace igniting for the first time in the vast emptiness. These stars, though very different from the ones we see today, played a vital role in beginning to illuminate the universe. And as they ignited, the universe, once a place of pure darkness, started to gain form and light. But stars didn't emerge alone. As they were born, other cosmic structures began to form too, galaxies. They started to come together, gathering stars, gases, and cosmic dust, creating vast systems that began to organize into something greater. While these galaxies weren't like the ones we see today, they marked the beginning of the organization that would lead to the universe's complexity. Around this time, a very intriguing phase called recombination occurred. Before stars, the universe was filled with cosmic radiation, a kind of fog of particles and light that made it impossible to see anything. But when atoms began to form, radiation was released and the fog dissipated. This moment is crucial because it marks the transition from an opaque universe to one where light could finally travel freely through space, allowing us to see what was happening. This process of star and galaxy formation, along with the transition from radiation to visibility, was like the universe starting to draw its first lines. When we look at the sky today, we see those stars and galaxies shining, each carrying a story that traces back to these key moments like the emergence of the first stars or the formation of the first galaxies. And as we gaze at it all, we can't help but wonder, what more is waiting to be discovered in the future as the universe continues to expand and transform? We've reached the end of this incredible journey through the universe. And as we reflect on everything we've learned, we can better understand what the Big Bang truly represents. It wasn't an explosion in the traditional sense, but rather a continuous process of expansion and transformation that gave rise to what we see today. The Big Bang Theory helps us grasp how the universe has evolved, but it also reminds us of something profound. We are all part of this cosmic story. The universe, with all its stars, galaxies, and mysteries, connects us in ways we can scarcely imagine. Thinking about the Big Bang is more than imagining the beginning of everything. It's about reflecting on how we are pieces of this immense puzzle that continues to expand. Every new day, we are part of this cosmic journey, living in a unique moment where the past, present, and future of the universe are intertwined. I hope this video has sparked your curiosity and perhaps inspired you to learn even more about the cosmos. If you enjoyed it, don't forget to subscribe to the channel, activate the notification bell so you don't miss upcoming videos, and share this content with your friends. The universe is vast and full of mysteries, and together, we can explore it. If you like the content, make sure to subscribe to the channel and turn on notifications so you won't miss the next videos. Until next time, and may curiosity continue to guide us in every new discovery.